Hello students, in this lecture I am going to discuss about 8051 microcontroller assembly language programming. So I'll be taking the programs, I'll be discussing the instructions instantaneously so that you'll get to know how to do the programming for 8051 microcontroller. So let's start with the move instruction. So as you can see, like in this slide, move A hash 55h, it is move A comma hash 55h. I'm talking about the first instruction. So what does this instruction mean? Whenever you want to store any immediate data into a register, whether it is a register A, whether it is register B, or it is any register from R0 to R7. So it is like if there is any register and you want to store the immediate data into a register, then you have to precede that data with a hash sign like here. So whenever you're writing any data with a hash sign before it, it means that this data will get stored in the register. So this is how you're going to store any immediate data into a register. Now next, this is for move instruction. Now if you want to copy the content of any register, like if you want to copy the content from any source register to a destination register, how you will be writing the program? Like for example, mov r0 e. R0 is also a register, A is also a register, both are 8-bit registers of 8051 microcontroller. So what this instruction will do, it will copy the content of register A into register R0. Like in the first instruction we copied this immediate data into the register A. So now the value of A is 55h. And in the second instruction, what we are doing, we are copying the content of register A into register R0. So now what is the value of R0? R0 is also equal to 55h. So what this move instruction will do, it will copy the content from this source register to a destination register. So the content of source register will remain unchanged even after the execution of this instruction, but the content of destination address will get changed because the content of source register is being copied to the destination register. Now again the next instruction, mov r1 comma a. So what does this instruction do? It will copy the content of A into the register R1. So again, since in the previous instruction I told you the content of register A is copied to R0, but the content of register A will remain unchanged even after execution of this instruction. So in this instruction also, what is the content of R1? R1 is equal to 55h because we stored the value 55h into the register A. Now next instruction is mov r2a. Again what it will do, it will store the content 55h into the register r2. Now mov r3 hash 95h, again the same thing. If you want to store any immediate data into a register, you have to precede that immediate data with a hash sign. So which means microcontroller will get to know that this is an immediate data that is going to get stored into this destination register. So the value of R3 will now be 95h. And the last instruction, mov a r3, again this instruction means we are copying the content from a source register to a destination register. Now one more thing I would like to mention, like I've told you, when you have to store any immediate data into a destination register, you have to precede that immediate data with a hash sign. So this instruction means mov r0 comma hash 40h means r0 will get stored with this immediate data. So this is called direct copy. So here hash means 40 which is in hexadecimal format is a immediate value which needs to be stored. Now if you are writing the instruction mov a comma r0, it means you are storing or you are copying the content from the source register to a destination register. And the last instruction MOV A comma @R0, it means when you want to store the content of a memory location where the memory location is specified by the register, you will be using this instruction. For example, if R0 is equal to 40H, suppose if R0 is equal to 40H, so MOV A comma @R0 means the value of the, or you can say the content of this memory location. The content of the memory location whose address is 40H will get stored into the register A. Again, I am repeating, whenever you are using @ in front of any register, it means the content of the value of this R0 will get stored in register A. So what is the content that is going to get stored in register A? It is the content of the value of R0. Value of R0 is 40H. Here I am assuming 40H. So the content of the address or the content of the memory location whose address is 40H will get stored in the register A. Now next is, there are certain things that you need to remember while programming the 8051 microcontroller. As I've told you that any value that needs to be stored directly into any register, it needs to be preceded with this hash sign. As you can see here, as you can see in these instructions, all the instructions, they are preceded with the hash sign, which means these all are immediate data. Like this instruction, what does this instruction mean? It means store the immediate value 23H into the register A, because this immediate value is preceded with the hash sign. So after execution of this instruction, what is the content of A? A is equal to 23H. Similarly, as you can see, the second instruction MOV R0 comma hash 12H, after execution of this instruction, R0 will be equal to 12H. Similarly, the next instruction MOV R1 comma hash 1FH means R1 will get stored with this immediate data 1FH. So in the same way, all the instructions are there, but as you notice this instruction MOV R5 comma hash 0F9H. So whenever you are storing any data which is in hexadecimal format and it is in letter, like we know in the hexadecimal number system we have 0 to F. The hexadecimal number system consists of 0 to F. So if you have to store any data, any hexadecimal data like F9 into any register, like if you have to store this data F9 in hexadecimal format in the register R5, what you're going to do, you're going to use this, obviously this hash sign, because it will represent this is the immediate data that needs to get stored in R5. And one more thing you need to do, you need to use 0 in between hash and this data, because whenever there is any letter like F and it is preceded with this hash sign, so there must be a 0 in between hash and the letter to represent that it is a hexadecimal number. So as you can see here also, in the instruction R5 0F9H, 0 is used between hash and F9 F to represent that, which represents that F is a hexadecimal number and not a letter. In other words, if MOV R5 comma hash F9 H you are using, for example, if you are simply writing MOV R5 comma hash F9H, it will create error. Microprocessor is not going to understand this instruction, it will create error. So whenever you are using any letter, any hexadecimal number that is starting with a letter like F9 or A9 or A1, like any hexadecimal number that is started with any letter, you need to use hash, you need to use 0 in between hash and that letter. Now next thing you need to remember is that when you want to store any hexadecimal number from 0 to F into a 8-bit register, So you can simply write, like if you want to store 5, if you want to store number, hexadecimal number 5 into a register A, what you're going to write? You're simply going to write MOV A comma hash 5. So the result will be, what does it mean? The rest of the bits, they will be assumed to be all zeros, because 5, if you write 5 in binary, it will represent a 4-bit binary like 0 1 0 1. The rest of the bits will be 0 0 0 0. It is assumed by the microcontroller. So whenever you're going to write any number from in between 0 to F in any register, if you're going to store any number in between 0 to F in any register, then you can simply write in this way. The microcontroller will assume rest of the bits to be 0. Now next thing is that if you want to store any large number into a 8-bit register, for example this instruction, as you can see this instruction, MOV A comma hash 752H. Obviously 752 is more than 8 bits. If you write this 752, if you write this 752 hexadecimal number in binary, it is obviously more than 8 bits. So if you're going to store any larger number into a 8-bit register, it will cause error. It is not possible. So you will not be able to do that. You have to use 2 registers for storing any number that is more than 8 bits. Now, and the last thing that you need to remember is this: value to be loaded into a register must be preceded with the hash sign, otherwise it means to load from a memory location. For example, what I'm trying to say is this. For example, MOV A comma 17H, and again MOV A comma hash 17H. So I'm trying to tell you the significance of this hash sign. So what is the difference between these two instructions? Both the instructions are having the same register and same value. So what is the difference between these two instructions? So MOV A comma hash 17H, what it will do? It will store this immediate data into the register A. Now register A will get stored with this 17H. Whereas this first instruction MOV A comma 17H, what it will do? It will store the content of the memory location whose address is 17H and store that content into the register A. For example, the content of memory location having address 17H, let the content be 40H. So after execution of this instruction, A will get stored with this 40H. So this is the significance of hash sign. So if you forget to use hash sign in any instruction, then the instruction is valid. Microcontroller is going to execute this instruction, but as per the user or as per the programmer, the exact data will not get stored in A. So what will happen? The content of the memory location whose address is 17H will get stored in A if you forget to use this hash sign. So this is all about the initials of the 8051 assembly language programming. In my next lecture also I'll be discussing about this programming. I'll be discussing few programs with you. So I'm ending this class here. Thank you.